Welcome to Quantum Online Academy. This is your Dr. Nagaraju Pendam. Today we are going to give another important topic introduction, that is condensed matter physics. This is very important for GATE and CSIR, both of the exams. But last time I told mathematical physics, classical mechanics, quantum mechanics, thermodynamics and electromagnetic theory. In their core syllabus is there in CSIR and advanced syllabus also is there. But here only advanced syllabus is there. There is no core syllabus. For CSIR only part C questions will ask condensed matter physics. Only 3 questions they will ask. Only 3 questions, 15 marks weightage for CSIR. In GATE, 8 questions they may ask each and every GATE season. It will come 16, around 15 marks weightage is there in GATE examination. But in CSIR you have to remember only advanced part is there. In this video, we are discussing about the condensed matter physics syllabus for CSIR and GATE and how the exam pattern for condensed matter physics in CSIR and GATE, and then old questions syllabus. How I am explaining, I am segregating the 10 parts. Each and every paper I am segregating 10 parts. That is very easy to study and to refer and to revise the subject. Clear? Now we will discuss that one. Which one we have to discuss? Syllabus, pattern of the exam and solution of some old CSIR questions. CSIR and GATE questions. More CSIR questions I took. Now you have to see. CSIR part B, only advanced is there. For condensed matter physics, only advanced syllabus is there. There is no core syllabus. So please remember, there is no core syllabus for CSIR condensed matter physics. Only advanced part is there. How many questions they may ask? Only 3 questions they may ask in CSIR examination. Only 3 questions. 3 5 ja 15 marks. Only 5 marks questions they will ask. No short questions. Clear? Now we will see condensed matter physics. It is a very interesting area. If you sound in condensed matter physics, all research is based on the condensed matter only. In Hyderabad, Defense Laboratory is there, that is DMRL one laboratory is there, that is purely material science laboratory. Next ARCI is there, that is also purely material science laboratory. If you have to go to the Charlapalli side, CSir-net laboratory is there, that is also purely material science laboratory. Wherever you go, in Hyderabad only 3-4 laboratories are there, purely material science laboratory. Otherwise, you have to go to the Central University, IIT, State University, Department of Physics. You have to enter as a research student or a research scholar. You will face only material science subject only. You know what is the crystal, what is the crystalline, what is the nano size, what is the micro size, how we have to calculate the energy gap, bandwidth, lattice indices, Miller indices, Miller parameters, everything we have to calculate by using a condensed matter physics only. You have good strength enough in condensed matter physics, you able to do good research, you able to interpret your ideas nicely if you have this much of basic you have, right? Now we have to see what is the syllabus is there for CSIR. Please remember only advanced part. First, Bravais lattices, that is a simple cubic, base centered cubic, face centered cubic, body centered cubic. 4 systems are there. These 4 systems we have to explain in 14 ways. The Bravais scientists explained these ways. Those lattices we call it as a Bravais lattice. Next, lattice, that reciprocal lattice also is there. That is also very important. Diffraction and the structure factor, diffraction and the structure factor you have to see. Bonding in solids. ionic bonding, covalent bonding, metallic bonding, hydrogen bonding, van der Waals bonding. Such type bondings you have to learn. Their bond energy, modeling constant, cohesive energy, everything you have to learn from bonding in solid. Elastic property, this is very, very important. How we are discussing about the photon, in the similar way, material also exhibits some energy, vibrational energy. That vibrational energy of the packet, we call it as a phonon. In elastic properties we are discussing, that is the phonon theory. There we have to discuss about the lattice specific heat. Next, you have to take a conductor. Their free electron theory is there. Electronic specific heat you have to represent response and relaxation phenomena. Their free electron theory, that is Drude Lorentz electrical theory and thermal conductivity, electrical conductivity, all affect thermoelectric power. This is very, very important topics. Electrons in a motion of a periodic potential, band theory of solids, metals, insulators, semiconductors, superconductivity, their superconductivity type 1 and type 2 superconductors, Josephson junctions, superfluidity. There, suppose you have to take a mercury 3, mercury 4, mercury 2 is there. There is a superfluidity. Defects and dislocations, first order, second order, third order, one dimensional, two dimensional, three dimensional defects are there. Ordered phases of the matters, translational order and orientational order, kinds of liquid crystalline order, quasi crystals. This is your syllabus. The syllabus I segregated in 10 parts. Now you have to see after some time. This is core syllabus. From this syllabus, how many questions you may get in CSIR? In CSIR, only 5 questions. Only, sorry, 3 questions. Only 3 questions, 3 5 ja 15 marks you may get in CSIR examination. Those condensed matter physics or solid state physics questions very, very easy. Everyone can do. Such type of easy questions are there. This is the thing. Now see the exam pattern. Now already you know the CSIR exam pattern part A, that is the general aptitude. General aptitude, 20 questions you may get. 15 questions you have to do. Each and every question 2 marks. If you lose 1 mark for wrong question, so 0.5 marks. That is for wrong question. This is completely general aptitude. General aptitude matlab emphasis of the logical reasoning, graphical analysis, analytical and numerical ability, quantitative comparison, series formation and puzzles. This is the part A. Part A is the same. Now for condensed matter, there is no part B. For condensed matter physics, there is no part B questions. Please remember, for condensed matter physics, there is no part B questions. Only part B questions for only 6 topics. For condensed matter and atomic molecular physics and nuclear physics and particle physics. Nuclear physics and particle physics, there is no part B. Only part C is there. In part C, for condensed matter physics, how many questions you, out of 33 questions for condensed matter. Out of 33 questions for condensed matter, 3 also you have to attempt, no problem. Each and every question 5 marks. For wrong answer, 1.5 marks you may lose. Please remember, total 55 physics questions they may ask in CSIR. All the videos I discussed this one. Variety of the thing, only one is there. For condensed matter physics, only 3 questions you may get in CSIR. Only 3. That 3 questions also 5 marks question. Not for GATE, only CSIR. Please remember that one. Next, GATE. This is section A. GATE syllabus is section A. Solid state physics. What is the GATE syllabus? Once you have to see. What is the GATE syllabus for condensed matter physics or solid state physics? Condensed or solid state, both are the same. First, elements of crystallography. This is Bravais lattices, crystal Bragg's law, Lave equations, entire the thing will come here only. Elements of the crystallography. Next, diffraction methods for structure determination. To know the structure of the material, we have to go for the diffraction technique. Whether it may be X-ray diffraction, Lave diffraction, powder diffraction, whichever is available in your laboratory, for that you have to choose. That is the diffraction methods for structure determination. Next, bonding in solid is there. This bonding in solids, there also exist. Lattice vibrations, elastic property, that one, thermal properties of the solids, free electron theory, bond theory of the solids, there also is there. Nearly free electron, tight bonding methods. This is very, very important. From the bond theory of solids only, this is the application of the bond theory of the solid, tight binding metals. Metals, semiconductors, insulators. Bond theory of the solid will distinguish the materials three types. One is a insulator, semiconductor, metal. That one is conductivity, their mobility, their effective masses, and this one is very, very important. Next, we have to see optical properties of the solids. That optical property is a Kramer's method, Croning relation, intra and interbond transitions, dielectric properties of the solids, dielectric function, polarizability, ferroelectricity, magnetic properties of the solids, diamagnetism, paramagnetism, ferromagnetism, antiferromagnetism, ferrimagnetism. These things are there in CSIR statistical mechanics. But a statistical mechanics advanced part, this magnetic material covered there. But in GATE syllabus, they are doing in magnetic material here in solid state physics. Domains and magnetic anisotropy. This is very, very important. Magnetic material also very, very important. Superconductivity. Next, once again you have to see which one, that one. Superconductivity. This area is very, very important, whether it may be GATE examination or CSIR examination. Type 1 superconductors, type 2 superconductors, Meissner effect, London equation, BCS theory, flux quantization. These all phenomena are there except magnetism in CSIR also. In CSIR also, except magnetism, some part is not covered in CSIR, some part is not covered in GATE. What are the parts we will see after some time. What is the exam pattern of the GATE once you have to see? This pattern is the same. For general aptitude 15 marks paper, 1 to 5 questions carry 1 mark, 6 to 10 questions carry 2 marks question. Now physics 85 marks is there, 11 to 35 questions 1 mark question, 35 to 36 2 marks questions are there, 36 to 35 2 marks questions are there. There 3 varieties of questions are there. One is multiple choice questions, second one is multiple select questions, third variety is numerical answer type question. Multiple choice question, multiple select type question, numerical answer type question. 3 varieties are there. These 3 also existing in condensed matter physics also. Clear? Condensed matter physics also, these 3 things are existing. These are very, very important GATE pattern. Now, I am giving one information. So, please see the reference books. Which books we have to refer? Because condensed matter physics or solid state physics is heart of the physics. This one is the physics only. We are discussing about the solids. We are studying about the solid. Which type of the solid? Whether it may be magnetic material, whether it may be optical material, whether it may be electronic material, whether it may be liquid, whatever whether it may be quasi-crystal, whatever it may be, we are discussing about that state. We are discussing about that material. Means we have to follow from standard book. Those standard books are very, very important. From condensed matter physics, so many varieties of books are available. Among all the varieties of books, I chose 7 books. Number 1, you have to see Solid State Physics, Ostrov Mermin. This book is very nice book, old version, old book it is. But even though this is a very nice book, Solid State Physics by Mermin. Next, Solid State Physics by S.O. Pillai is from Chennai. He wrote nice book. S.O. Pillai, Problems and Solution also is there in Solid State Physics. Next, Introduction to Solid State Physics, Charles Kettle. This book is, everyone knows, whoever did the MSc, their Kettle book is very nice book. Their solution also is there. Kettle Problems and Problem Solution also is there. Next, Solid State Physics by M.A. Wahab. M.A. Wahab, this book is very nice book. Their solution book also is there. Problems and solution also is there. Next, Solid State Physics, A.J. Decker. This book is Bible for Solid State Physics. That much of standard is there. Solid State Physics for A.J. Decker. This book is very nice book. Solid State Physics, Mihalje and Martin. L. Mihalje and M.C. Martin. This book also very nice. Physics of Semiconductor Devices. If you want to expertise in semiconductor devices, maybe if you read this one, in electronics also you will get the clear idea. Physics of Semiconductor Devices, Z. S-Z-E. This book is very nice book. These all books are very nice, very important books. Maybe if you have to know, otherwise in online mode also these books are available nowadays. You download and you have to read these books. You will get the more idea in solid state physics. How we have to represent the crystal plane, how we have to represent the direction of the crystal plane, how we have to represent the Miller indices. Everything you come to know from these 7 books. Clear? This is the book reference book story for a condensed matter physics. Now we have to discussing about, I am giving one information. What is that information? We want to go to start one new batch, that is a CSIR and GATE batch. Starts from 7th January 2024 onwards. This batch is purely online mode only. Live plus recorded classes are there. If you like my teaching, if you like my attitude of the teaching, my way of teaching, then you decided so to join, to go to the Play Store and download my app. That app is Quantum Online Academy. There, Quantum Online Academy, go to the Google Play Store and download my app. From that app, you have to purchase the batch. If you have any doubt, you call my number. These are my numbers. My regular number is 9908437460. My institute number is 63032633368. So please share my channel and subscribe my channel and share to your friends also to make them as a subscribers. So please encourage me. Your subscribers will give me the motivation to me. After some time I have to teach the current affairs in English mode and science and technology also in English mode I will teach, right? Now you have to see how I am segregating the condensed matter physics. Each and every paper I segregated 10 parts. Total 9 papers are there in CSIR. These 9 CSIR are GATE also 9 papers are there. Previously this paper was solid state physics with electronics combination is there. Now GATE wala also they changed into the 9 papers. They give the section 7. They are giving in the solid state physics. They are segregated. A solid state physics is alag and electronics is alag. Clear? Now I am segregating total 10 parts. Now you have to see crystallography. Whether question may come, that is 5 marks question only in CSIR. What is the weightage? Only 15 marks in CSIR. 16 marks you are more than 16 marks you get in GATE examination. Each and every area, any area you have to take, you will get only 5 marks only. Whatever area you have to take, you will get the 5 marks only. Suppose if you have to see here, this optical, dielectric and magnetic properties of the solid. If you have to take a optical, dielectric and magnetic properties of the solid, this part is not there in CSIR. Only GATE. This one is only GATE syllabus. So that's why you remember for 2 marks you may get from the GATE here. Suppose you have to see here defects and dislocations are there. This one only for CSIR, not for GATE. This only for CSIR. Ordered phases matter and quasi-crystal, this syllabus is also only for CSIR because these areas are burning research areas. Recently they produced the theory. That theory is ordered phases of matter and quasi-crystal. This entire area only for CSIR, this area only for the GATE. But now you have to see superconductors, GATE also important area and CSIR also important area. Bond theory of the solids, GATE also important area and CSIR also important area. All effect on thermoelectric fever, GATE also is there and CSIR also is there. Free electron theory, Drude free electron theory, Sommerfeld free electron theory, whatever the theory if you have to take, whether it may be classical free electron theory, quantum free electron theory, you will get the here only specific heat and thermionic emission, everything will come under this. This is also GATE and CSIR both is there. Elastic properties, phonon theory, all the thing you have to learn from here. Also specific heat for a lattice vibration, there also we have to Debye theory, Einstein theory we are learning here. This is also important. Bonding of solids and crystallography. These are 10 parts I segregated. If you learn like this, you are expert in SSP. SSP matlab solid state physics or condensed matter physics. Clear? Like this, from each and every area, I have to chosen one question. From each and every area, one question I will explain in this video. You have to listen and enjoy my class. Now you have to see. In June 2015 CSIR, they are asking one question. A X-ray of wavelength lambda is equal to A. What they are giving first, whatever it may be, if they gave the problem, first you have to write the data. Whatever the given data is there, that data you have to write. Which data is there, Nana? Lambda is equal to A. Lambda is equal to A. The X-ray of wavelength lambda is equal to A is reflected from which plane? That is 1, 1, 1 plane. This plane is Miller indices plane, HKL plane. Here H is equal to 1, K is equal to 1, L is equal to 1. This is the HKL plane they are giving. Plane of a simple cubic lattice. It is a simple cubic. A is equal to B is equal to C. This is the simple cubic. Which one it is? Simple cubic lattice. Now, if the lattice constant is A, the corresponding Bragg's angle they want to ask. What is the Bragg's diffraction formula? 2D sin theta is equal to n lambda. Here n is the order of the diffraction pattern. If you have to consider the order of the diffraction pattern 1, if they are not, they are giving, you have to take it as a 1. If they will give, you have to enter it. Not give, you have to take it as a first order. Which order it is, Nana? First order. N is equal to order of the diffraction pattern. Now you have to write 2D sin theta is equal to lambda. What they are asking? They are asking about the diffraction angle. Theta is equal to how much? First you have to calculate the D. D is a interspacing distance. D is equal to, for cubic crystal, D is equal to A by square root of H square plus K square plus L square. A only is divided by that lattice constant is equal to A only. H square plus K square is equal to 1 square plus 1 square plus 1 square. How much you got, Nana? A by root 3 you got it. A by root 3 you got it. Now you have to substitute, you calculate the theta value. 2 into A by root 3. D is equal to, I am substituting A by root 3 into sin theta is equal to lambda. Lambda is equal to how much? Lambda is equal to A get cancel. Sin theta is equal to root 3 by 2. Theta is equal to, which one we have to write, Nana? Sin inverse root 3 by 2. Root 3 by 2 is equal to 60 degrees. In terms of radians, how we have to write? 5 by 3. Theta is equal to 5 by 3. 5 is equal to 180. 180 by 3 is equal to 60. How much answer you are getting? 5 by 3. Option C is correct. Like this you have to do. How many marks this question? 5 marks in CSIR. How simple it is you have to see. Just if you know the Bragg's relation, automatically you have to know what is the angle, Bragg's angle. What is the Bragg's angle? 5 by 3 is a Bragg's angle. Clear? Like this we have to do. This question belongs to the crystallography. Not only this, sometimes they may ask void space, sometimes may they ask the packing fraction, sometimes may ask effective number of the electrons, whatever it may be. Sometimes they may ask the Wagner-Zeiser cell, whether it may be Wagner-Zeiser cell is existing or not. Sometimes they ask lattice constant, how you have to calculate, like that they will ask. Any question, that area is like that. 5 marks in CSIR or 1 or 2 marks in GATE examination they will ask. Next, the second question. What is the second question you have to see? The potential from bonding in solids. Every time this question pakka you will get in CSIR or GATE also. Every question paper, whatever it may be, if you are going to write a National Testing Agency question paper, you must face this type of question. Please listen. What is the potential of a diatomic molecule as a function of the distance r between the atom is given by, they are giving potential data I am writing, V of r is equal to minus a by r to the power of 6 plus b by r to the power of 12. Minus a by r to the power of 6 plus b by r to the power of 12 they are giving. What they are asking? The value of the potential at equilibrium separation between the atoms. The value of the potential at equilibrium distance. V of r is equal to r naught. Then how much they are asking? How we have to calculate? First you have to see. At the equilibrium, one condition is there. At equilibrium, what we have to take, Nana? Though V of r is equal to 0, when at r is equal to r naught. At equilibrium point, the first derivative with respect to the position is equal to 0. First you have to take V of r. First you have to calculate. Though V of r is equal to minus into minus plus 6a is divided by r to the power of 7. At r is equal to r naught also you have to take r naught to the 7 plus minus 12b by r naught to the power of 30. I am differentiating with respect to r. Now what is this, Nana? This is equal to 0. According to the definition, at equilibrium point, though V of r by though r is equal to 0. 0 is equal to 6a by r naught to the power of 7 minus 12b by r naught to the power of 13. First you have to calculate the r naught value. How we have to calculate the r naught value? 6a by r naught to the power of 7 is equal to 12b by r naught to the power of 13. 7. So 13 means how much it will come? 6 it will come. R naught to the power of 6. 6 1 ja, 6 2 ja. Therefore, r naught to the power of 6 is equal to 2b by a. R naught to the power of 6 is equal to how much we are getting, Nana? 2b by a. R naught to the power of 6 is equal. This r naught value you have to substitute there. How we have to substitute? Once you have to see V of r is equal to V of R is equal to R naught is equal to, which one they are giving? Minus A by R naught to the power of 6 minus A by R naught to the power of 6 plus B by, which one they are giving, Nana? Plus B by R naught to the power of 12. I am substituting. What is the R naught is equal to? 2B by A. R naught is equal to 2B by A. You have to substitute there. Minus A is divided by 2B by A plus B is divided by 2B by A whole square. 2B by A whole square. Now you have to see here. So minus A square is divided by 2B. Denominator by denominator it goes to the numerator plus B into A square is divided by 4B square. 1B get cancelled. Now you have to see here. Take the LCM. Which one it is? LCM is a 4B minus 2A square plus A square is divided by 4B, which is equal to V of R is equal to R naught is equal. Minus A square plus A square matlab how much? V of R is equal to R naught is equal to minus A square by 4B. This is your answer. Now once you have to check your answer. What is the potential at equilibrium position? The potential difference at equilibrium position is equal to minus A square is divided by 4B. How much we are getting? Minus A square is divided by 4B we are getting. So like this we have to do. This is very important type. You always you will get such type of question. Such type of question in CSIR you may get. Such type of question in GATE also you get. In CSIR sometimes you may get in 3.5. Whether it come from condensed matter physics, this pakka 5 marks question only in CSIR. Clear? Now we will see the third one. What is the third one? Elastic property. In elastic property you have to see a uniform linear monoatomic chain. Which one it is, Nana? Monoatomic chain. Monoatomic chain. In a uniform linear monoatomic chain is modeled by spring mass system. This uniform monoatomic chain, how we are modeled? By using a spring mass system. Spring and mass system, a uniform modeled chain is there. Now the masses m separated by a nearest neighboring distance a and spring constant beta. If you have to take beta is equal to m omega naught square. The dispersion relation for this system. Already we know the dispersion relation for a monoatomic chain. Which one it is? Dispersion relation. Dispersion relation for a monoatomic chain is equal to omega of k. What is the dispersion relation? It is a relation omega versus k. The propagation constant versus omega angular frequency. Such type of relation we call it as a dispersion relation. Omega of k is equal to square root of 4 beta is divided by km. 4 beta is divided by m into sin ka is divided by 2. But what is the beta value? Beta value they are giving. Omega of k is equal to square root of 4 into m omega naught square is divided by m into sin ka by 2. 1 m get cancelled. 4 omega naught is equal to which one we have to write, Nana? 2 omega naught into sin ka is divided by 2, which is equal to, that is a dispersion relation. Omega of k is equal. What is your option? Your option is equal to, you have to see this A is wrong. Which option is correct, Nana? B is equal to correct. omega of k is equal to 2 omega naught sin Ka by 2. Very simple. How many marks you will get? 5 marks you may get. When they are asking 2013 CSIR, in 2013 December, they are asking such type of question. Just you come to know what is the dispersion relation for a monoatomic chain, dispersion relation for a diatomic chain. Like that you have to know, you come to know, you have to do. Very easy and such type of questions. Now you have to see next. What is the next one? Electrical free electron theory. This is the Drude-Lorentz theory. From Drude-Lorentz theory I took this question. The electrical conductivity of the copper. What is the principle of the electrical conductivity? Electrical conductivity sigma is equal to n e square tau by m. Sigma is equal to n e square tau by m. There what they are giving, now you have to see, this is the formula. The electrical conductivity according to the Drude-Lorentz rule, free electron theory. From free electron theory you have to take this one. The electrical conductivity of the copper is approximately 95% of the electrical conductivity of the silver. The electrical conductivity of the, which one it is? Copper is equal to 95% of the electrical conductivity of the silver. Electrical conductivity of the silver. Sigma Cu is equal to 0.95% of sigma Ag. That one is over. Now you have to see electrical density, electron density. Electron density in silver is, electron density in silver Nag is equal to, electron density in silver is approximately 70%, means 0.70% of the electron density in copper. Electron density in copper, right? In Drude's model, they only gave the approximate ratio. This is the relaxation time ratio. Which ratio it is, Nana? Relaxation time ratio. The relaxation time ratio, tau copper by tau Ag is equal to how much they are asking. How we have to write here? Once you have to see how we have to write. They are giving sigma copper is divided by sigma Ag is equal to n also varying. That's why n copper is divided by n Ag into tau copper is divided by tau Ag. You have to take. What they are asking? Tau copper is divided by tau Ag they are asking. Therefore, tau copper is divided by tau Ag is equal to sigma copper is divided by sigma Ag into n Ag is divided by n copper. Now you have to substitute. Sigma copper is equal to how much, Nana? 0.95 into sigma Ag is divided by sigma Ag, right? N Ag is equal to how much? 0.70 n Cu is divided by n Cu. N Cu get cancelled. Sigma Ag get cancelled. Now you have to multiply 0.95 into 0.70. How much you have to get it? 0.66. That is the ratio. What is your option? Your option is 0.66. Like this. Very simple. If you know the formula according to the Drude-Lorentz model formula, what is the electrical conductivity? Sigma is equal to n e square tau by m. When they are asking in June 2016, how many marks you have to get it? 5 marks. It is very easy. If you know the quantum mechanics, mathematical physics, electromagnetic theory, you have to solve so much of derivation part is there. Then only you will get the last answer. But here not like that. Here just you remember the formula, you apply the formula, you will get the answer. easily you have to get the 15 marks. 15 marks easily you have to get in CSIR. Only 3 questions you may get, not more than 3. Only 3 questions. That weightage of condensed matter physics for CSIR only 3. But in GATE you will get more number of questions. 7 or 8 questions you may get in each and every time. This is the option D. Now we have to see the next one. Consider two-dimensional material length L and width W subjected to a constant magnetic field. We have to take a two-dimensional material that width is W, length is equal to L. Therefore, area A is equal to, what should I write, Nana? Area is equal to length into width. That area we have to take it as a length into width. One material we are keeping in the magnetic field perpendicular to it. The number of charge carriers per unit area may be expressed as, what is they are giving? Charge carriers they are giving K into Q, B is divided by 2 phi H cut. This is the KQ charge carriers are expressing, where K is a positive constant, K is a positive constant, real number, and Q is the real number, Q is the carrier charge. Then the all resistivity along the XY is, they are asking. All resistivity they are asking. Which one they are asking? This is the all effect phenomena. The very important. December 2017, recently they are asking this question, right? This question is very important. Now you have to see resistivity, how much they want to know. How we have to calculate the resistivity? You have to take a semiconducting material, you have to apply the magnetic field, their electrical charges is produced, those electrons we call it as a Hall electron. That type of phenomena we call it as a Hall effect phenomena. First, resistivity general formula, rho is equal to RA by L. R is the resistance. Resistance is equal to, which one we have to write, Nana? According to the Ohm's law, VH by I into A by L. So therefore, which is equal to rho x comma I is equal to VHA by I into L. What is the VH? VH is a Hall voltage. This is very important. What is the VH? VH is the Hall voltage. All voltage VH is equal to, which one we have to write, Nana? I into B is divided by, I into B is divided by NQW. This is the Hall voltage formula. This is very important. So please remember, all voltage formula is equal to IB by NQ into W. Now you substitute rho x comma y is equal to, VH means IB is divided by NQW. VH is equal to, now you have to see this is A is divided by, which one is there in the denominator? I into L is there. Current get cancel. Area is equal to L into W, get cancel. Therefore, rho x comma y is equal to B by NQ. B by NQ. Already they are giving the N value. That value you have to substitute. Now I am doing here. I don't want to take one more thing. You have to see. Rho xy is equal to B is divided by, which one they are giving, Nana? N is equal to KQ, B is divided by 2 phi H cut, 2 phi H cut into Q, 2 phi H cut into Q. BB get cancelled. The denominator by denominator it goes to the numerator. 2 phi H cut is divided by KQ square you are getting. What is the resistivity? 2 phi H cut is divided by KQ square. What is your option? C is your option. So 2 phi H cut by KQ square. This is very easy. How many marks you are getting for this question? 5 marks in CSIR. 5 marks in CSIR. If you are right option you have to enter, you will get the 5 marks. If you have to enter the wrong option, you may lose the 1 mark. Right? This is very, very important. This question from all effect and thermoionic emission phenomena. Now the next one we have to see. What is the next area you have to see? Bond theory of the solids I segregated. From bond theory of the solid I took. A bond structure calculation, the dispersion relation they are giving. Which one they are giving? First data, whatever the data they are giving, that data I am writing. Dispersion relation E of k is equal to beta into cos kx plus cos ky ka plus cos kya plus cos kz a, cos kz a, where beta and constant a is a lattice constant. The effective mass at the boundary condition of a first Brillouin zone. What is the boundary condition of the first Brillouin zone? Kx is equal to plus or minus 5 by a, comma ky is equal to plus or minus 5 by a, comma kz is equal to plus or minus 5 by a. This is the first Brillouin zone boundary condition, right? Whenever we have to do that bound theory of solids, there we will discuss. In Chronic-Penny model also we have to discuss. What they are asking? Effective mass, M conjugate they are asking. What is the effective mass? Effective mass is equal to how much they are asking. What is the formula for the effective mass? M conjugate is equal to h cut square is divided by dou square E of k is divided by dou k square. This is the formula. First you know one thing, E of k you know. First you calculate the first derivative. Dou E of k is divided by dou k. With respect to k you have to differentiate. Beta is a constant, right? Cos theta you have to differentiate. How much you have to get, Nana? Minus sign kx into a. Again you have to differentiate a, it will come, that a I have to take. Everywhere a it will come. Minus sin ky into a minus sin kz into a. You have to substitute like that. Again, once again you have to differentiate. Dou square ek is divided by dou k square is equal to a square into beta. One a already I am bringing. Here minus cos kx into a minus cos ky into a minus cos kz into a. Correct? Now you have to substitute first Brillouin zone. At kx is equal to 5 by a. At ky is equal to 5 by a. At kz is equal to 5 by a. How we have to get? Beta a square into cos 5 by a. You have to substitute. What will happen, Anna? A get cancelled. Cos 5 is equal to minus 1. Minus into minus plus. Plus 1 plus 1 plus 1. Total 3. How much you are getting? 3 beta a square we are getting. Now you substituted here. M conjugate is equal to, the effective mass is equal to h cut square is divided by 3 beta a square. This is your option. Now you have to see option D is correct. H cut square is divided by 3 beta a square is there. Like this we have to do. This is very, very important. So many times, so many exam people, sometimes they may ask what is the effective mass formula directly. Sometimes they are asking the formula also. Sometimes they may give the question also. Like this we have to do. And we know the thing. What is the thing? First Brillouin zone boundary condition also we come to know. Then only we get the option. Otherwise big task is there. First you have to take differentiation. Later you have to substitute the boundary conditions of the Brillouin zone. Then you will get the answer. Clear? Like these questions you may get in your CSIR examination when they are asking December 2012 CSIR time. December 2012 they are asking this one. Now you have to see here electrical property, thermal property from optical property. This property question they may get only GATE only, not CSIR. Like that's why I took from GATE only, I took GATE 2010. The valency electrons do not directly determine, do not means not involving, do not directly determine the following property. Electrical conductivity, conductivity का मतलब free electrons involving here, free electrons involving, right? Electrical conductivity, free electrons are involving, not correct. Thermal conductivity, here also thermal conductivity means thermal free electrons are involving, it is also not correct, right? Shearing modulus, shearing modulus is there is no electrons are there, this option is correct. Here metallic luster, here also metallic means there is a free electron is there, here also free electrons, metallic luster also consists of the free electrons, clear? That's why which is the answer? Do not contain the free electron, that is shear modulus is do not contain the free electron nature, clear? This is a this one is very important. Only GATE people will ask like this question. This question based on the optical property, thermal property, electrical property, magnetic property question, clear? Now we will see the next one. This is very important superconducting question. In December 2013 they are asking this question. A DC voltage V is applied across a Josephson junction. What is a Josephson junction? You have to see. Two varieties of Josephson junctions are there. One is DC Josephson junction, another one is the AC Josephson junction. This one, which one it is belongs to? AC Josephson junction. How you have to remember? You have to see. First, one superconductor you have to take. This is the superconductor 1. One more superconductor you have to take here. This one is a superconductor 2. These superconductors you have to apply a DC voltage. Which voltage you have to apply, Nana? DC voltage you have to apply. Then you will get a charge carriers. Here microammeter you have to keep. You are getting the charge carriers. Here which current we are getting? AC current you have to getting. AC current. This effect, such type of effect we call it as a AC Josephson junction. AC Josephson junction effect. AC Josephson junction effect. From AC Josephson junction effect, how much current they are producing? Big derivation is there. That current I will give. I is equal to I naught into sine of, which one we have to write, Nana? 2eV by h cut into t plus phi naught. This is the phase difference between these two junctions. What is the angular frequency? Sometimes they are asking the question. Omega is a angular frequency. If you have to take a angular frequency, what is the angular frequency of Josephson junction? Omega is equal to 2eV by h cut. What is the option? Option A is the correct option. I naught sine 2eV by h cut plus phi naught, where phi naught is a phase difference. Direct formula they are giving. You have to identify that formula. You will get the 5 marks question. That's why I told solid state physics questions. Only 3 questions you are getting in CSIR. These 3 questions also very simple questions. Easily you will get the 15 marks in CSIR without negative also. Like this you have to read. Sometimes directly also they will ask. This question, defects and dislocation question. Suppose 4 varieties of dislocations are there. There is a point dislocation, that point defect, that is the zero dimensional defect. Line defect, there is a 1-dimensional defect. Surface defect, there is a 2-dimensional defect. The volume defect, there is a 3-dimensional defects are there. Like this, here there is a defect is there, that is the 0-dimensional defect. The energy required to create the lattice vacancy.
lattice vacancy matlab it is a ionic vacancy. Ionic vacancy. Ionic vacancy matlab this one is a which type of defect? This defect is a Schottky defect. Schottky defect. Which defect it is, Nana? Schottky defect. Schottky defect. To the energy required to create this defect, how much energy required? Is that energy is equal to 1 electron volt. They are giving the data. The energy required to create the defect is equal to 1 electron volt. The ratio of the number densities, vacancies. The ratio of the number densities they are asking. The ratio of the N1200 Kelvin is divided by N300 Kelvin. N1200 Kelvin is divided by 300 Kelvin. What is the Kelvin temperature? That T1 is equal to 1200 Kelvin. T2 is equal to 300 Kelvin. T2 is equal to 300 Kelvin. What is the number density for a Schottky defect? N is equal to capital N into exponential of minus E by 2 kb into T. This is the formula. You have to substitute now. So, which one you have to substitute? N1200 Kelvin is divided by N300 Kelvin is equal to N1200 Kelvin means exponential of minus E by 2 kb into 1200 is divided by N into exponential of minus E by 2 kb into which one we have to write, Nana? 300 you have to write. N get cancel. Now you have to take the common. Which one is common? N1200 Kelvin is divided by N300 Kelvin is equal to exponential of, you have to take this one upside, denominator, numerator you have to take it as, it is a positive, it will come. E is divided by 2 kb, you have to take the constant, 1 by 300 minus 1 by 1200. Now you have to take the LCM of 1 by 300 and 1 by 1200. Exponential of E is equal to, now you have to substitute 1 electron volt, a 1 into 1.6 into 10 to the power of minus 19 is divided by 2 Boltzmann constant, 1.38 into 10 to the power of minus 23, 20 to the power of minus 23 into, we have to take it as a 1 by 400. Which one it is, Nana? 1 by 400. You have to simplify this. How much value you are getting? Exponential of 30 you are getting the value. So what is your option? Your option D is correct. This is very, very important. Like this also they will ask. When they are asking June 2012 in CSIR examination they are asking. Somebody doing the engineering degree. So there the syllabus is there. So Schottky defect, charge carrier density, Frankel defect, charge carrier density. They are producing the derivation part also. That is very, very important. So please remember, we have to do like this. This is the 9th defects and dislocation. Now the 10th one we have to see. What is the 10th one? This is a very burning research area. Burning matlab whatever the research is going on nowadays, that research area we call it as a liquid crystal, quasi crystal, that research area. Based on the liquid crystal, we are producing some waveguides, electronic goods we are producing on the liquid crystal. Material is a surface, material is a basement of the electronic good. That's why we need the physics. Physics is a fundamental thing. Without physical state, we can't establish any electronic good or any good in the entity, in the universe. Clear? Which of the following liquid crystal has a helical structure? This is very, very important. When they are asking TS set state eligibility test people in 2018, they are asking this question. There are liquid crystal, three type of phases are there. One is nematic phase. Which phase it is, Rana? Nematic phase. One more phase is smectic phase. Smectic phase. One more phase is cholestatic phase. Cholestatic phase. Now you have to see the nematic phase means the atoms are vibrating translational vibration like this. In smectic phase, the atoms are how accuracy translational vibration is there like this. In cholestatic phase, so the cholestatic phase, one layer is like this, one layer is like this, one layer is like this, one layer. Layer by layer by layer it is rotating. Such type of rotation we call it as a helical rotation. Which structure is helical phase, Nana? Cholestatic phase is a helical phase. Clear? This is very, very important. So many times these theoretical questions are coming from a liquid crystal and a quasi crystal. This is the advanced area of SSP or condensed matter physics. These 10 areas, 10 questions I told. In each and every paper I am discussing like this. I am uploading the YouTube. So please listen and share my channel to your friends. Those also will be get the benefited because of this is free only. No, in YouTube it is free. If you really like my teaching, if you really want to achieve the CSIR or GATE examination, if you really want to crack the examination, you have to go to the Play Store and you download my app, that is a Quantum Online Academy app. From that app, you have to purchase the course CSIR GATE course from 7th January 2024 onwards. Live plus recorded classes are available in that, right? So daily we have to take the classes from 6 a.m. to 8 a.m. Only single teacher, not another teachers we won't get. Some another expert I will call and I will give the motivational lecture to you. Some topics also I will engage with some another teachers also. But I won't believe other teachers because how they are teaching, what they are producing, which type of questions they will cover, what type of syllabus they will cover. I am unable to believe them because this is a CSIR batch. I want to teach all syllabus with 1 year course. This is not 6 months or 3 months or 2 months. 1 year course. To complete this syllabus, all year it will take place. This entirely 1 year course, 1.5 year validity I will give to you. 1.5 year validity. If you have to purchase my course, 1.5 year validity is there. Every Sunday we will conduct the exam. Every day we have to discuss the questions. Every day we have to discuss the theory. We have to discuss entire the syllabus, whatever the syllabus is there, entire the portion we have to cover. Whatever the thing you go to the Delhi, you go to Hyderabad, wherever you go, such type of, this type of orientation you won't get in anywhere in India, right? Now, thank you so much. Thank you for your listening. Please share and subscribe my YouTube channel. We will meet with another video. Thank you.